Welcome to BKW Physics. I'm Mr. McConnelly, and today we're going to do two demos that focus on the idea of center of mass. And the first one, kind of a classic demo, this is just a newer version of it, is I have this little hammer here, and this hammer has a steel head on it, and then it's just got a piece of plastic tubing. And so I just want you to know that this is a pretty heavy hammer, for the size of it anyway. And what I'm going to do with this is I'm actually going to slide this bent piece of metal into the handle of the hammer a little bit. And you can see it's heavy. You can see the way it's kind of like elongating the steel. And then I can hook this right on the very edge of the table, and that thing will just hang there. In fact, I can turn it. Okay, it's kind of like one of those things you might see in the store, one of those balancing, like the bird that balances on with the wings or whatever. And what's neat about it, if you think about it, is that this thing is hanging from the very edge of the table, and this heavy hammerhead is actually underneath the table. And it doesn't seem like, when you first look at it, it doesn't even seem possible, but the idea of center of mass is that this point right here lines up to the balancing point of this hammer. The balancing point of this hammer must line up something like there. So if I were to take this hammer, I could probably balance it right about there. Now it's hard to because you balance it like this. Yeah, that's just about the balancing point. The handle and the hammerhead, it's just hard to keep it there. But the handle and the hammerhead are basically balanced at that point. So that is the center of mass. Now on a person, generally, your center of mass is somewhere around your belt line. Now if you have a different build, like you're really heavy up top, and really skinny legs, or really heavy legs and really skinny body, your balancing point, your center of mass could be up or down from that point. But generally, your center of mass is at your belt line. And so I played basketball quite a bit growing up, and what they always told me, my coach told me, is the person can't move until their waistline moves. That is actually a statement of the center of mass, because once your center of mass starts moving, you're moving. You can fake and move your upper body or make your legs go like this and try to fake somebody, but until your belt line moves, you're not going anywhere. That's a center of mass idea. Now here's another one. I have a nail that's in a piece of plywood, and I have these other nails. How many do I have? 2, 4, 6, 8, 10, 11 other nails. And I can balance these 11 nails on top of this nail. And a lot of you are like, I don't know about that. It seems pretty tricky. But of course, there's a little bit of a trick to this. And it takes me a second to get this set up. But basically, I put the one nail this way, and then I start arranging these nails, alternating back and forth, in a way so that I can get these all kind of squeezed like this, and then I use this nail to kind of close the top, we'll say. Now here's the hardest part. This is the part I always mess up on 3 or 4 times. I get frustrated, so the video might go a little long. But basically I have to keep that all squeezed as I set it on top of here. Oh, I lost one. I can recover. Maybe. Maybe not. Ooh, I got it. Alright, so you can see that using the concept of kind of hooking the nails together a little bit, those nails will balance on the one nail that I have in the wood. Now this is a center of mass thing, because you can see there's mass poking out in all directions, because each of those nails have mass. But if you take all those masses and treat them as one system, that one system has a balancing point right there on the head of the nail below it. That's another center of mass demonstration. So I'd like you to, as we close this video, think of other examples of center of mass for today, physics.